Hello, and welcome everyone. Thank you for taking the time to attend today in the latest Protectowire webinar series, Mastering Your Next Fuel Tank Install with Protectowire Linear Heat. My name is Amy McCarthy, and I am the technical salesperson here at Protectowire for the US and Canada. My position here at Protectowire allows me the great privilege of speaking with many of you on a regular basis. For those of you who don't know me, I am here to assist in all things technical, from choosing the right Protectowire linear heat detectors and equipment, to troubleshooting and all that falls within. Technical sales is what I do. Over the past year, our sales and marketing teams have created great webinars on the following subjects: 5 benefits of CTI, a quick guide to installing, an in-depth look at 7 applications, Protectowire integration, and a beginner's guide to flame detection. Protectowire webinars are concise, informative, and well attended from all points of the globe. The feedback we've been receiving has been positive and enthusiastic, and I'm thrilled to be adding to the Protectowire webinar series today. My goal today is to review the factors that come into play when protecting fuel tanks with Protectowire linear heat detection. The topics and flow of this webinar will hopefully clarify some points while reviewing all of the basics. So if any topic should seem rudimentary, please understand that there is a method to my madness, as all topics connect, with the end goal being the successful fuel tank installation with Protectowire linear heat. So the best place to start is defining the hazard. Defining a classification is based on the type of hazardous material involved. As shown in the snapshot of NEC and IEC standards, gas and vapor are the highest risk, and typically the classification defining tanks and tank farms. Now, Protectowire has distribution around the world, and I'd like to clarify that this is just a snapshot of the NEC and IEC standards, and it is not meant in any way to get into the intricacies of classification around the globe. Again, it's just an overview to identify a classified hazard. Most tank installations are outdoors, and it is important to note that a classified hazard in the exterior does not necessarily mean the hazard is declassified. Always consult the authority having jurisdiction for all site requirements. When dealing with classified hazards, nothing should be assumed. Always consult the authority having jurisdiction for confirmation. Now that we've defined our classified hazards, there are 2 ways that are most commonly used in our industry for protecting classified hazards. First, we have explosion-proof devices. Devices capable of containing any explosion originating within that device, preventing sparks within the device from igniting vapors, gases, dust, or fiber outside that device. The second mode of protection is intrinsically safe circuits. A circuit equipped to control excess electrical energy under normal or abnormal conditions, preventing the possibility of ignition of vapors, gases, dust, or fiber in the surrounding area. So when thinking about these 2 methods, Protectowire is not an explosion-proof device. Protectowire is a linear heat detector that requires exposure to the environment it's protecting. So intrinsic safety makes sense. You want that Protectowire to come into the hazard on an intrinsically safe circuit. And this is an important conversation. Often when I'm speaking to people on this subject, the methods of explosion-proof almost sometimes get intertwined with the method of intrinsic safety. So this part of the webinar is really about defining how Protectowire is listed in a classified hazard and the steps that we take for you to follow to ensure the listing. And the next slide, I'd like to talk about the intrinsically safe barriers that we install here at Protectowire in our control equipment to create the intrinsically safe circuitry. Intrinsically safe circuitry is achieved by the use of intrinsically safe barriers installed in our control equipment. The intrinsically safe barrier creates an intrinsically safe circuit compatible to the Protectowire linear heat detector being used. The shunt diode works when excess voltage appears across the detection circuit. The internal Zener diodes with current limiting resistor shunt the excess voltage to ground. This diode is used on the CTM 530EI interface module, the PIM 530EI interface module, and the Protectowire control panel FS2000 with the option H. Note that the option H disables ground fault detection on the panel. Therefore, on the FS2000, we also offer a DC isolator, option K. This device provides galvanic isolation between internal panel wiring to the respective detection circuit wiring, disabling ground fault on the initiating device circuit only. And here we have a quick visual on our control equipment, the FS2000 with the shunt diode option H or the DC isolator option K. Then we have the CTM 530EI, which is the intrinsically safe interface module for the CTI series linear heat detector, and the PIM 530EI, which is the intrinsically safe interface module for the Protectowire PHSC linear heat detectors. So we've gone through a few steps of how to figure out the classified hazard, the control equipment, and now we're going to put it all together with the Protectowire control drawing. Note that this drawing is divided into two halves. You have the non-hazardous location and the hazardous location. Protectowire control equipment is always going to be in the non-hazardous location. And it makes sense, right? Because the Protectowire control equipment is housing the intrinsically safe barrier. So you want to make sure that all of that's in place and working before you enter into the hazardous location. Note the transition into the classified hazard. The installer would be responsible for the appropriate gas-tight feed cable and seals running in conduit to the first zone box, where then you would transition to the Protectowire linear heat detector. Note that this drawing is shown in a Class B configuration. That is how Protectowire is listed. You must terminate the zone inside the hazard in a Class B configuration as shown on this installation control drawing. So it's not just one element of Protectowire that can go into an intrinsically classified hazard. The intrinsic safety and the installation drawing are collective, and it's the installation itself per this drawing that is our listing. You'll also note on this drawing that there is an inductive and capacitive loading chart. Depending on the group of the classification, this could affect your zone length. And I'm only bringing it up, I'm just touching on it so you're aware of it. If anyone has any questions on that, you can give us a call and we'll help you with that, figuring it out. This drawing doesn't represent a complete control drawing. I just took bits and pieces of one for the purposes of this webinar. So now let's move on to protecting the tanks themselves. Protectowire detection by tank type. So yes, we are finally going to speak about the actual tanks themselves. I know that there was a lot of preamble to get here, but it's so important. Such important stuff. And I really do appreciate you hanging in there and kind of absorbing all that we just spoke about, which is a lot, but it really does clarify what is required for a correct listing with us. So let's move right on to tank types. Okay, so the first tank we're going to talk about is a fixed roof tank. I love this picture. You get a lot of views in this picture. You've got some ring sprinklers. You've got the safety railings going around the top. You've got the stairway coming up to the relief valve. So there's a lot going on. You can see ancillary piping, the dock out to the ocean. All of this qualifying for Protectowire in every way, shape, or form. So this is a great view of a tank farm. And I'm going to move on to the next slide. Continuing fixed roof tank protection. Protectowire in this case is installed around that safety rail that we saw in the previous slide, and it is attached with the TR5G, that insulated standoff. It's a great picture showing that installation going up and around the exhaust vent as well. Protectowire for these type of installations, the type would be PHSC XCR, or if you're using the CTI series, it would be CTI-X. The XCR and the X are the fluoropolymer outer jacket used for exterior or harsh environments. You always want to use the XCR or the X jacket in these kind of environments. And now that we're looking at this installation drawing over on the far right, you can kind of remember the installation control drawing that we talked about, and it shows that the Protectowire, the conduit is going back to the control equipment that would be outside the hazard. So starting from outside the hazard, in up to the tank, and then the appropriate gas tight copper is going to transition in that first zone box to Protectowire. We're going to run around the top of that tank, just like it's shown, up to the relief valve and back, and then ending in a Class B config, just like the drawing. There's your listed installation for a fixed roof tank. Remember, any site-specific requirements will always be determined by the authority having jurisdiction. So any questions or requirements or approvals, always talk to the authority having jurisdiction on that particular job. Now we're going to move on to floating roof tanks. The first type of floating roof tank we're going to talk about is an open air floating roof. And you can see from this drawing, it's pretty self-explanatory. It is a roof that moves with the level of the contents of the tank. Now, open air floating roofs are pretty easy to install because there's nothing inhibiting access to the Protectowire installation. So we'll move on to the next slide where we can see the detail of installing around the rim seal. Okay, so now we are looking at a nice side cut of a open air floating roof tank. You can see the ladder that floats up and down with the contents of the tank. The Protectowire linear heat is typically mounted in the foam dam. There is a retractable cable that we offer that would come from the first zone box down to the second zone box, and running in a Class B configuration, which I will show you on the next slide. This is a great cutaway. Again, thinking about the control drawing, all the control equipment is outside the hazard, and you're going to be using the PHSC XCR, or if you're using the CTI series, you will be using the CTI X. Stainless steel mounts are recommended in this kind of environment. Again, we're going to show you the retractable cable, the MS3091T. And as always, site-specific requirements determined by the authority having jurisdiction. If you look to the far right of this slide, you'll see a drawing depicting the MS3091T retractable cable. Just to clarify, this picture shows the zone boxes applicable to Protectowire PHSC XCR. This standard Protectowire PHSC requirements. Now, the retractable cable comes down from the first zone box. You can see where the conduit comes in with the appropriate gas tight cable from outside the hazard, connects to the first zone box, which connects to the first leg of the MS3091T. Follow that down and you will see another zone box where the Protectowire runs in a circular configuration around the foam dam. Now, when you follow the power back up the retractable cable, you'll notice that there's an end-of-line resistor in the top of the first zone box. There's your Class B configuration. When installing Protectowire, we recommend that you use stainless steel mounting brackets. Here's an example of taking two of our stainless steel mounting brackets and attaching them to each other. If you attach that OHSS clip to the RMC3L bracket, it's a nice little mounting accessory where the Protectowire can sit right in between the two. You can also do the same with the JD1 clip as well. Now, once the Protectowire is installed, Maintenance and inspection have to be considered. You're not going to just put Protectowire in and forget about it. Maintenance and inspection is required, and if something goes wrong or there's an issue, the mounting brackets and the detector itself will need to be visually inspected to troubleshoot, as well as inspections. So keep that in mind whenever you're installing Protectowire. You want to make sure that the install is accessible. Okay, so we're moving on to internal floating roofs. Now, we just spoke about accessibility. If the Protectowire installation is going to be inside the internal floating roof, accessibility is required whether the tank is empty or full. If that accessibility is there, then typically you could treat it as the open air floating roof and install around the foam dam. If accessibility isn't available, then manufacturer's recommendation is treated as a fixed roof tank. Very simple. Again, the detector that you would use is the PHSC XCR, or for the CTI series, you would be using the CTI-X. And remember, all site-specific inquiries should be addressed to the authority having jurisdiction. So here's a nice slide depicting cylindrical tanks. You can see that there's a nice picture of Protectowire attached with double loop straps to a messenger wire, which is connected to the tank via eye-bolt. And the key to installing Protectowire is to not stress it out. This is a really nice installation. And remember, Protectowire is amazing, but we're only as good as we're installed. And I cannot stress that enough. You want to stick to the 2.5-inch bend radius. You don't want to stress out the detector. You don't want to create 90-degree angles. You really need to install with the idea that you're installing a linear heat detector and not just wire. And I think that gets lost in translation a lot. So again, we are only as good as the install out there. So this is a great installation. It also shows above some deluge, which is often where Protectowire is placed in these kind of environments. The picture over to the far right shows a maze of connection pipes, which is also a fantastic application for Protectowire. We actually manufacture Protectowire with a messenger wire. It's a 0.034 316 stainless steel. This photo actually is aircraft cable by others with Protectowire attached to it, but just to put it out there, we do offer a messenger wire that is wrapped around the detector at the factory, and it's connected via eye bolts and turnbuckles. So that's something to think about. So again, the detector you would be using in this environment is the PHSC XCR, or if you're using the CTI series, you would be using the CTI-X. And remember to always consult the, authority having jurisdiction for all site requirements. In the previous slide, I was talking about proximity detection and ancillary piping. I think this fuel loading station gives you a really great visual of all of that. A perfect application for Protectowire. When thinking about proximity heat detection, there couldn't be a better product than Protectowire. Proximity detection meaning on or as close to the hazard as possible. And Protectowire is the perfect example of a detector that can get on or as close to the hazard as the application allows. Again, by treating it with the respect the detector deserves, keeping to a 2.5-inch bend radius, using mounting fasteners that don't stress out the detector, considering the type of detector, the jacketing, the temperature, all of this comes into play, especially when you're dealing with these types of hazards. It comes into play with any hazard. Now, what happens if you need to install in a situation like this non-invasively? If you cannot drill because of the potential of a spark, if you cannot tap into any of the structure that is being offered, then you need to think of a way to install, again, non-invasively. And here at Protectowire, we have a couple of solutions to that where we can offer you the BC3 beam clamp, which is fantastic for these types of applications because looking at this visual puzzle of piping, there is just so many ways a beam clamp could work. You could attach the OHSS clip or the JD1 stainless steel clip to the BC3 clamp as well, giving you a more durable fastener for the exterior. We also talked about messenger wire. Messenger wire is a great way to span from point A to point B, where you would only have to attach and support infrequently, so your amount of surface attachment is reduced. I think one of the biggest installation errors I see on a regular basis is when Protectowire is zip tied directly to a pipe, and there's no flexibility for the detector to breathe. There's no slack in the installation. The detector's clamped down so tight that mechanical damage could happen. I think this is one of the types of installations that really riles me up because it happens so often. And it's not intentional. It's just the lack of knowing that whoever's doing the installation is working with a detector rather than a wire. Anyone that I can preach to on this subject, and today you are my captive audience, so I guess you're stuck with me on this one, but it's just a matter of simple respect. I said it again, I'm sorry, I don't mean to keep going over it, to the detector when installing it. Because it is a device, it's something that needs to be cared for when installing. And again, I mentioned it before, the 2.5-inch bend radius, and allowing a little slack in between your fasteners so the Protectowire can ebb and flow, so to speak, if it's outside with the seasons, because it's going to constrict and contract whether it be cold or warm. So again, it's just those little things that you don't know if you don't know. And the right mounting fastener can make all the difference. In fact, the JD1 clip can be put on a stainless steel strap. The strap is by others, but we offer the clip. The stainless steel strap would go over the piping or the beam, whatever you are attaching to. The JD1 clip sits off the strap, and the Protectowire sits in the JD1 clip. So that would be another non-invasive way of being able to attach Protectowire all around this pipe puzzle fueling station. And now we can move on to our next tank. So I did want to touch on spherical tanks or natural gas tanks during this presentation just because they're coming up on my radar a lot more. I mean, these tanks have been around since the 40s, but they really do seem to be coming across my desk more often than not. Commonly, these tanks have multiple sprinkler rings around the diameter, which is a fantastic place to install Protectowire. The same principle is involved. Control equipment outside the hazard using the Protectowire PHSC XCR, or if you're using the CTI series, the CTI-X. And that is the subject of my next slide. I want to talk about the detector itself, the PHSC XCR and the CTI-X. Over the course of this presentation, I have said PHSC, XCR, and CTI-X probably a million times. So if you take anything away from this presentation, it'll be you know what detector to order. Now let's talk about alarm point temperatures on those detectors and how those alarm point temperatures relate to the max ambient temperature of the environment they're being installed in. In both PHSC, XCR, and CTI-X, the alarm point temperatures most commonly used are 190 degree, which is 88 C, 220 degree, which is 105 C, or 280 degree, which is 138 C. Now, these alarm point temperatures also have a recommended max ambient temperature, meaning that we would like the detector not to be exposed to the maximum ambient temperature for long periods of time. The 190 degree at 88 C has a max ambient of 150 degrees, 150, that's 66 C. The 220 degree has a max ambient of 175 degrees F, that's 79 degrees C. And the 280 F at 138 C has a max ambient of 200 degrees F at 93 C. Now, the reason you need to know this is because if you are installing in any part of the world that has extreme heat in the summer months or just extreme heat anytime, you want to make sure that the max ambient is covered on the detector that you choose. If the detector is exposed to the max ambient for long periods of time, it may soften the heat-sensitive polymer inside the detector. On the flip side, these detectors are tested to 40 below zero, which I believe is 40 below zero C as well. So the cold shouldn't really be the factor. It's thinking about the heat aspect, thinking about the environment where the detector is going. And this is universal on any installation. Is the detector going into a machine shop where actual machinery is going to add to the max ambient, to the ambient temperature of the surroundings? So it's a good thing to know. It's a good thing to think about when you're considering the alarm point temperature for whatever application you have. Earlier, I did touch on the XCR and CTI-X outer jacket, the fluoropolymer outer jacket. That is our most robust jacket for exterior or harsh environments. It's got a high chemical resistance as well as abrasion resistance. So know your jacket when you're picking a detector as well. Know what that outer jacket is, because that's equally as important as choosing the correct alarm point temperature. So the next few slides will just be a recap on the control equipment and install fasteners that we had discussed previously. The control equipment available with intrinsically safe barriers for classified hazards. Again, the FS2000 control panel with the option either H or K. The CTM530EI interface module for the CTI series linear heat detector, or the PIM530EI interface module for the PHSC linear heat detector. Here we have the JD1 clip. I touched on this briefly when I was talking about the L bracket, attaching the OHSS clip to the L bracket. Well, this is another clip that you can also attach to the L bracket, which makes for a nice, easy stainless steel installation. The JD1 can also be attached to piping with a stainless steel strap by others. So this slide is a visual on the OHSS clip attached to the L bracket. I know the picture's kind of lame. I took it with my phone, but I thought it was important to show you. It's connected with a stainless steel screw by others. So again, whether it be the OHSS or the JD1, it's a great combo for tank installations for sure. This is the data sheet for the retractable cable. The maximum extension is 99 feet, which is 30 meters. I'd like to point out that this retractable cable can be wired for both the standard Protectowire PHSC or the CTI series CTI-X detector, depending on the application that you have, what system you're using. Again, the same retractable cable can be used again both for the PHSC Protectowire and the CTI Protectowire. We've touched on a lot today. In summary, remember to always define your hazard. Remember to choose the correct Protectowire linear heat detector based on outer jacket and alarm point temperature. And remember to always adhere to the Protectowire control drawing supplied with all intrinsically safe control equipment. And consult the authority having jurisdiction on any specific site requirements or approvals. So this concludes my webinar, Mastering Your Fuel Tank Installation with Protectowire Linear Heat. I hope you enjoyed it. I really enjoyed presenting today. I also host a podcast that you can find on our website called the Lowdown on LHD. LHD, of course, standing for Linear Heat Detection. My podcast was designed to address the most common issues I come across in my position here of technical sales. I do my best to keep it light and fun, so please check it out if you're interested. Again, many thanks for joining me today, and know you can contact us anytime at info@protectowire.com, or you can reach us at 781-826-3878. From all of us here at Protectowire, thank you very much for attending today.